Yes, we are.
Awesome. Well, we got one more. Hey, welcome. There's an empty seat here.
Yeah, and also get something to drink here. Is that where everybody? Yes. Awesome. We are at the top and shoulders at the bottom.
Cool. Well, let's begin. So welcome to Copenhagen.rb Brigade with Aption. I think we'll start. My name is Christian, and I'm going to do the first track, web development with Elixir. And I've been really looking forward to this. Jamie talked me into doing this talk like a month ago, when we were still working together. So what's Elixir anyway? Do any of you guys know Jose Valim? Yeah, he's like a Ruby hero. He wrote a hell of a lot of Ruby gems, including simple form, a lot of Rails code.
Nice.
That too. He wrote a couple of books, crafting Rails applications. Yeah, two of them actually. And he's a really clever guy. And he sat down a couple of years ago now and learned Erlang. And he thought, okay, let's add some syntactic sugar to this. And that actually spawned off Elixir, which he first released in 2012 May. That was the initial commit to GitHub. And I believe he also gave a talk in Soho for the Ruby Brigade a couple of months after he released Elixir. But anyways, why is Elixir so fucking exciting? Well, first of all, it's built on top of Erlang, and Erlang is this kind of old language now. It has like almost 20 years on its back. It's originally developed in Stockholm with Ericsson by a guy called Joe Armstrong and friends. And Erlang is like an exciting language because it scales beautifully, and it's distributed. And whenever you compile something with Erlang, all your calls light up on the activity monitor. That's just nice. And you can really build some awesome stuff with Erlang. And Elixir is built on top of Erlang. So whenever you're using Elixir, you can use all of the gems or beams, it's called. Whenever you compile something into Erlang, it's compiled into a beam file. You can use that in Elixir. So what can you walk away with after this track here? I'll show you how to do web development with one of the many frameworks Elixir has spawned off. So you can actually do a web app with Elixir if that's what you would like. Just a quick note, I would like to show you the differences between Erlang and Elixir. So I don't know if you can read this. This is actually quicksort in Erlang. That's pretty nasty, isn't it? I mean, what gives? Where's the def? Where's the end? And the def is actually that little error. Right here. That's function definition. And the end, that's of course the dot. Yeah. Okay. And how does it look in Elixir? Oh, this looks like Ruby. Yeah. We have got devs, we have some kind of module, and it's kind of more pleasant to look at than the other stuff. Okay, so now you had like a quick intro to what Elixir and Erlang kind of like is. So we're going to build a web app that will get all the commits from the Elixir Lang repo on GitHub, and some of the most common frameworks I've listed up here. We have Cowboy. That's actually the most active Erlang web server at the moment. Then we have Jaws. Jaws, like an old guy. It's been around since 2002. It has a lot of features, but it's not very active at the moment. Then we have Dynamo. And Dynamo is actually part of the Elixir Lang repo. Jose Valim is an active committer on Dynamo, and they set out to be a fast and concurrent web server, but it's very much alpha. Then we have Phoenix. Phoenix is, well, it hasn't got all the features that Dynamo got, but it's sort of more like Rails, so to say. And then we have Weber, and that's what we're going to use today. Weber is very much like Rails. It has controllers, partials, even layouts, and a lot of other stuff. But we're only going to build a really simple web app. It also has routers. So, next slide. Let's code. Yeah. Okay. I'm just gonna sit down for a moment and switch projects. If it's going too fast, then please stop me, and I'll slow down. So I've cloned the Weber project and installed it. So now I'm going to do a new web app. We do it like this. Makes Weber new, and that's kind of like we know it from Rails. Rails new, blah blah blah. And we're going to call it Elixir feed. There we go. Now we've created a new Elixir web project, and it looks sort of like this. This is the app. This kind of defines what do we start up when we launch our web app. And then we have some controllers, some helpers, some models. We can even do integration to a database if we want to using Ecto. Then we have our basic routing, our views, layouts, a main that's attached to the main controller, of course. Then we have our mix file. And the mix file is kind of like the gem file in a Rails project. Then of course we have the public directory, which is served by Cowboy at this moment. And beneath that, I've added some basic goodness like Bootstrap, so we can do a decent layout. Then there's some tests. There's a response test and some test helpers. But anyways, let's get down to brass tacks. So first of all, we're I'm gonna to my development environment. There we go. Cool. So let's crank up the mix SS. This is our dependencies. This is what we're starting up, and this is the dependencies that we're going to use. Last night I sat down and wrote an integration for GitHub. I call it Elixir commits. My handle. There we go. That project we need to start up. That's inets. For getting web content. You can kind of compare it with Nokogiri. That's kind of like the well, the most similar gem, so to say. But anyways, we're going to get our dependencies. Yeah.
So in that application array, you basically just like specifying the requires.
Yeah.
Okay.
That's kind of like.
So that they would load.
Yeah, I would like for it to get that dependency from GitHub, and this is what I'm doing here. Here it's first it's getting Weber, then it gets my Elixir project, then it gets Hackney and XJSON and Hackney lib, some other projects, and Cowboy, the Erlang web server. So this is kind of like bundle install. And you can even on this guy down here, you can add tags and versions, so you can name specific versions of repos if that's what you would like. But anyways, now it's done. We need to do one more thing before we can proceed. We need to get the requirements for the test environment. I don't know why it doesn't get that, but it continuously failed to do it. Okay, so let's tests. There should be like 2 tests. Now it's compiling a lot of stuff. And you can see my cores, they all light up. It's running on all cores.
That's when you go out for beer.
Yeah. Or that is actually when you go out and compile Erlang, you go out for a beer. So now we've got 2 tests that passed. That's good. Let's take a look at one of the tests. That's the. So this is like a response test, a basic unit test. It's a XUnit test case, and it kind of like looks like a simple unit for Ruby. So this is Hackney getting a request to localhost, calling Weber, and it'll get a 404 because that resource doesn't exist. That's okay. We want to do make the Elixir. Okay. We want it to give us a 200 just to get a failure. No, we don't. And why don't we do that? That's because we have nothing. And nothing is because the test cases start up the app, and whenever the app is started, it's started in the test environment. But we can launch the app, see what it is. We actually get a sensible reply from. So now we're kind of booting the entire stack.
Does it have live compilation? Change things on the fly and then.
No, it doesn't. It has that for templating, but not for the Elixir source files. You need to recompile them. Weber, hello. Right. So this is the basic front page. Right. And take a look at our main controller. Right. So what this does is that it receives no arguments, because no argument is specified in the router, and we don't use this variable. That's because it's underscored right here. That will tell the compiler to ignore it. And then we render out the default view, and the default view for this is this guy here, and that's a lot. So let's get rid of some of this stuff. Bye. So let's get a rel style. That's success bootstrap main css and a script source js bootstrap .js. And let's just save that, and then we need a body with a container with a page header, which has a h1, which has a elixir feed headline, which again has a h3, which has the elixir elixir framework here, and we have HR, and then we have a UL with a list group inside it. Yeah, that looks about right. Cool. So let's take a look at.
Close the head tag.
Close the head tag. Great. I missed that. Right. So now we changed our template. So let's take a look at this guy here. Cool. It updates. We have our elixir feed, and we're looking at elixir lang elixir. Cool. So let's just pop over here in the IEX. IEX is kind of like the REBL or IRB on Ruby. So let's look at elixir commit GitHub fetch page. So this is something I did yesterday. Boom. A lot of JSON. So this is actually what we're going to present in our web page. So let's go back here. So we need to pump out this into the template, and this kind of looks familiar if any of you tried coding ERBs. This is actually how we put that into our template. So now how do we go about presenting this? We need to call that module I just called before in the IEX session, and we need to present the result in a variable called commits. Let's just see if we can actually make our way into. Now we need to restart the web server because we're changing the elixir file. So now we should get the same template that we had before, like this, but with test beneath it. And we do. So our controller can talk to our template. Yay! That's good. So now we need our commits, and let's fetch our commits. The def-p is a private function. The commits. One. Commits, which is good. But we don't want to pump out that entire JSON feed into our template. We need some kind of way to filter it. So what we're going to crank up now is Elixir comprehension. And a comprehension is sort of like a way of iterating over something. So we're going to say for m, which is what we will call it. We will inject our commits. We will format the m. So this will go into our function here, which we call format commits. And the format commits will now turn in formatting the commits into something that is pleasant for the eye to look at, which would be a list item. And this would be a list group item. It's kind of sad because the Elixir language and all of the projects that try to keep up with it, it's really moving fast. So whenever somebody bumps the Elixir language, there's like a whole subset of projects that has this ripple effect, and they need to update to the current language specifications, since it's not 1.0 yet. So things happen fast. Anyways, what I'm doing here is I'm concatenating some strings, basically formatting the output, and we need to get the commit message. So we have that here. Whoops. Hello. Fumbly fingers. Okay. There we go. So now I'm taking a list item, and I'm adding a class, a list group item, and then I inspect the argument that we get, which is the hash for any type of message, and then I add it into the to the list item.
In Elixir, is it called hash? Is it actually a hash? Because I know that in Erlang it's a tuple.
Yeah, but it's one of the new features of well, it's not a hash. It's actually a map. Okay. That's what the Elixir commits GitHub fetcher is returning. But the JSON library that I'm using to parse it doesn't translate it correctly, so I can't do this, if I were to do this, if it was an atom, which this is called, then which is much nicer. But as you could see in this guy up here, all of these here are the strings, and they're not atoms. I don't know why it's not being translated into a correctly formed map yet, but maybe the guy doing XJSON will be so kind to update it whenever he gets the time. Until now, we have to get by doing this. So let's see where that takes. And we need to shut down the server and start it up again. Boom. Right. That didn't give us anything. And of course, it's because I'm still rendering test. Nice. But anyway, while I'm still doing that, let's do a maybe so right now this is generating lists of LIs. So it's actually what's inside message is actually strings with LI blah blah blah. Go away. Like this, and okay, my fingers are completely fucked now. Yeah. So this is actually what's inside of message, and we don't want that. What we want is one big string that we can just pour out into the template. And why do we want that? Because at the moment, I can't iterate over lists inside of this block here. I was going for something like 4x commits, and then the do render, and then I can actually give it a partial. That will be the. But that doesn't work. It gives me a hard error. Says you can't do that. Okay, so what's inside of the eval block here isn't actually evaluated, and the reason for that is because you're meant to put it inside of a helper, and then it can do some nice stuff for you. So I tried to do that, but I found out helpers doesn't work in this version due to a bug in Weber. So yeah, we had to do it the hard way.
So does it disallow this because it's like happening at runtime that it does it?
The reason for it doesn't allow it is the guy maintaining Weber hasn't fixed it yet. He's still struggling to get up on Elixir 0.13.2, which was released May 14th, which was last week. So what we're running on here is his preliminary release of compatibility with Elixir 0.13.2. But I expect it to be working sometime soon. That's living on the edge, so to say. Anyways, we were going to format this guy here, and that is string, which would be from chat, and then we give it the message. So what this guy does is it iterates over the message list, and concatenates all of the list elements into one big string. And we can pour that into our template. Let's just take a look at how that looks. Hello. So this is the latest commit messages from the Elixir project. It's about right. But wouldn't it be nice if we could see who actually made those commits? I'm just saying. I mean, it would be nice. So let's add one more function here. Format badge. And that would be a somewhat like the same span flag badge. Boom. And we need to concatenate that with the author. I need to spell correctly, would actually solve a lot of problems. The name of the guy. And we need to close the span. There we go. So now we're adding a badge to our template. Let's just see how that looks. Boom. Jose Valim and Andre and our guy Benjamin. I'm actually doing a review for this guy here, Benjamin Tan Wei Hao. He's doing a book on Elixir. I'm just going to do a small commercial here. The Little Elixir and OTP Guidebook, which is basically a collection of some of his blog posts on Elixir development, and it's going to be really great and cheap too. Oh, anyways, so now we have kind of like what we set out to do. We have a web page presenting the commit feed from GitHub. But how does it perform? What's the argument for actually going through this and writing apps in Elixir? That's a good question, and it deserves a good answer. So let's crank out the route. This is the router of our web app, and the way we add a new route is by piping on another route. Oops. I'm just going to copy that. Oh. So we're going to do a performance measurement here, and we're going to see how many requests we can actually get out of this. So what I'm doing is a plain controller, which will basically just so let's do a def module inside of the Elixir feed. Plain do copy this guy up here. Guys, I can never remember the syntax. So what we're going to write out is text, close. And we'll be writing out hello world. Okay, so let's reboot our server. Now we can do plain page not found, and that's because I need to do mix compile force. We're forcing it to compile it, and then we're restarting. Hello world. Cool. So let's just for kicks, I've prepared a small example, a basic rack server. Doesn't get any more simple than this in a Ruby world. And I even think, yeah, I did. I don't know, is Evan here?
He will be remotely.
Okay. But this is actually running on the same port as our, which, so let's just kill the Elixir app. Oh, I killed the other one. There we go. And this guy just puts out hello world everywhere. Cool. So that brings me to my next slide, so to say. Yeah, performance, of course. A basic shootout between a Ruby rack server and Elixir. And let's see what we can actually get out of it. Pardon? It started Redbrick. Oh, well.
This area is Ash.
Oh yeah.
You can just say Kuma. It's right, Kuma.
Like this?
Yeah.
Thought that was what I did. Yeah. And it boots Redbrick. Well, I don't know why. That's kind of weird. Anyways, let's do work, and let's just say 10 threads, 400 concurrent, and do HTTP, localhost 80. Look at it go. Okay, so 788 requests per second. Right, so let's kill that and fire up our Elixir server again. And I'm not going to get rate limited by calling our root app because it calls the GitHub API, and if I fire off that many requests, I'll get rate limited. I experienced that this morning, and let's not piss them off. So we're going to call the plain controller, this guy here, which is basically exactly the same as the rackup application. So let's see what happens. Boom. 23,394 requests per second.
How many cores do you have now?
4. Yeah.
someone shouted, that's insane.
Yeah, I mean, and that's just on your basic laptop. I mean, we're struggling to get our Rails apps to perform like 1,000 requests per second, and this framework just gives us 23,000 requests per second without even optimizing for it. I mean, that's kind of exciting. Let's just okay. So it's not really. It's fairly idle. It's not really loaded. So yeah. Okay. Cool. I don't know about you guys, but I think we can find a winner here.
By a small margin.
By a small margin, yeah. I actually did the same for Node.js, and they're somewhere in between. They hit off at like 11,000 requests per second, so it's sort of in between. Yeah. Questions?
What are you running? What type of Ruby are you running? Live?
2.1.1.
Yeah. So like there's no threading involved in that, so they make one different.
Not really.
You tried with JRuby?
No. I see the performance measurement on the Puma side, and I don't really understand it.
Maybe Evan can explain it.
Yeah, maybe, but I don't know. I just think it's kind of exciting.
Have you tried with other web servers?
With other web servers,
Other than Webbrick? Have you could of course it's something to do with that Webbrick might more heavy.
well, I was under the impression that it was Puma that we did it with, even though it did say we were.
I think it's because you are starting the bricks in this conflicts hardware backfire.
Maybe, yeah. Let's just kill it here. Okay. Let's not kill
You
it.
should be able to do dash S and Puma with backup.
Okay. So that would be Ruby config wrapper
No, just backup.
backup. And then
Dash S.
Puma. Let's see what happens. No? Same thing.
You know, the problem is you're probably not requiring Puma. Go up to the top of the part.
You said
With a large P in the backup?
Puma.
No, that shouldn't make a difference.
We can try it.
Can you
No.
skip the Webbrick line in the bottom of the configuration?
Sure. Oh yeah.
Can you
Oh, that's the
remove
problem.
Webbrick from Ruby?
Yeah, that's the problem.
Probably not. We'll start.
And then you have to say, go back to your backup file again. Run before. Yeah.
Yeah.
Okay, cool. So let's try again, just for kicks.
Excitement.
Yeah. Was 400. Did I have a duration on before? No, I didn't. Localhost. Oh yeah.
Well, those print statements are probably slowing. So if you can suppress, do it to dead null, like redirect to dead null. Or something.
Oh, it's way better already. Yeah.
But it's not up there yet.
Oh, not by a mile.
But I guess if you're, as he suggested, if you run it in JRuby, you have 4 cores available, right? And
And also those print statements are going to be really expensive for the processing time.
Yeah, maybe. So what do you suggest, Jamie? Like
redirect to dead long, but then you're not going to get the result. So when you
But the result is printed in a different terminal, isn't it?
yeah, we can do it like that. Where do we have that? 9292. Oh, yeah, it doesn't matter. Yeah, it's basically the same. Can write it to a file. See what happens. Pretty sure it won't make that much of a difference. No. Not
we'll leave it to
not really.
Evan to explain us how to do that.
Yeah. Okay. Yeah. But there we have it. Let's just see.
What was it? Was 23,000?
Yeah. We can do it again. Yeah. 23,600 requests per second. So, yeah.
23,000 to be fair with me.
Yeah, something like that. Let's round it down. But one of the interesting things is, well, low latency. Well, this guy's pretty low too, but yeah.
You didn't do any type stuff in your code, right?
Type stuff?
And you didn't cast anything to Ruby?
In Ruby?
No, in
Elixir? No. What it's doing is it's writing hello world, just like the Rackup application. That's it.
So does it compile to static?
Yeah. Yeah.
So it kind of just guesses it, or?
No. Don't ask me about how the inner workings of Erlang and Ruby or Elixir actually works. I know it compiles into some kind of binary bytecode, but from there on, I got no idea what's going on.
Now I'm interested in knowing if that's just a big if there's actually a really big difference just by being compiled, or is like Elixir really fast compared to other compiled languages?
No.
Like, let's say C# or
Yeah. I'm fairly sure that this kind of performance out of the box is just due to the concurrency in Erlang and the OTP framework. The OTP framework is like a generic framework for packaging really heavy-duty server stuff. So you can do like a finite state machine or a generic server or TCP server or whatever you like. And it's you can do it with actors, so it'll be really fast and concurrent. And you can run it on all your cores if you like. Where you need to do something active in Ruby to do that.
so the OTP would actually handle all the, let's say, it's called the sharding in between the.
There's CPUs. Yeah, exactly. It's an easy way to do really scalable code without shooting yourself in the foot or having to worry about ACID or mutex or stuff like that. So yeah, that's pretty much wraps up my my talk. Unless we got more questions.
Is request may build Go
Yeah. Yeah.
Have you experimented with that?
I haven't experimented with Go, but I've heard a lot of good stuff about it.
Yeah.
We have a Go user there. Yeah.
Anyway.
Okay.
Isn't it like just like C?
No, it feels more like Ruby 5.
Okay.
Okay.
That surprised me a lot.
Yeah.
So you said that it's scaled pretty easily, and it's obviously multi-core, right?
Yeah.
But how does it?
And-
Can it automatically just
and-
scale your code out on multiple threads, or do you have to like spawn threads and stuff?
Yeah, you need to spawn processes, but the OTP framework will do that for you.
So just pardons of your requests automatically.
Yeah.
What about concurrency errors, like if you try to access the same hashes and share resources?
That's all wrapped in actors, supervisors, and workers. So it has like a supervisor worker tree. So if one process dies, if one worker process dies, its supervisor will maintain its state and restart it without influencing other workers or supervisors, and that makes it really, well, really hard to kill, so to say.
Isn't it like every function is a process? So
Yeah. Yeah.
How's the deploy tool? How easy it is to deploy the server?
Well, there's actually made what's it called? A build book or something, a deploy book, I think, to Heroku. So you can just add that as a dependency, like I did with my module. Then you need to add a file or something, a proc file, and then you can just push it to Heroku and it runs. Yeah. It's very easy. One of the guys from Heroku, Fred Hibbert, wrote a book on Erlang. It's called Learn Use of Erlang. It borrows the format from Haskell with permission, of course, and he talks a lot about distributed code where you have multiple nodes. Making two nodes talk together in Erlang is very easy. You just name your node when you start it up, and then give it a cookie, and then you have two nodes that talk together, and then you can actually write code on one node and send it off to the other without having to FTP or anything, making the other node just reload the code and use that hot code swap. Yeah. He says it's really awesome, and you can get almost 100% uptime, but it's a hell to maintain, mostly because you need to do some kind of rel-ups for guarding against running processes, so their state won't be expunged, so to say. He actually suggests if you can afford to kill the VM, then do it and restart it. It's much easier, but it is possible. So yeah, cool. As a side note, I read a blog post a couple of months ago where a guy set out to see how many requests could he actually press through at Erlang VM, and he set out that he wanted to do 1 million concurrent requests, which is kind of a lot. So he started off doing 10,000, then he did 100,000, and then he did some calculations and figured out he needed a box with 24 gigabytes of RAM. Then he could do it. And so he bumped up an EC2 instance and did his test. I mean, it's kind of awesome. Yeah. Anyways, that's all for me. Thanks.
If you can get a million requests per second, you probably can afford the machine to do.
Yeah, exactly. There are systems out there which handles several millions requests per second on Erlang. Yeah, not Elixir yet. It's
Does the Elixir compile down to the same bytecode as Erlang does?
Yeah, and you can actually load Elixir programs on the Erlang REPL. They're just prefixed with the module Elixir. So you can do Elixir code on
You don't have to install any
Erlang and the other way around. No,
No.
you just need the Elixir language and then you're good to go. So it compiles down to the same bytecode.
You can call like the other language from there.
Yeah, and that's what this is doing. This is calling Cowboy beneath it. I can actually call Cowboy from within my controller here if I want to. I can call Cowboy. I don't remember the syntax, but it's something like rel, and then I can get the key per string from the connection, and there I have it. That I'm calling Erlang. So it's very interchangeable. If
And are any of those web servers already on Pinot?
Oh yeah, I mean Cowboy is running hardcore production service.
Okay. So is Weber on Pinot?
No, no,
Okay.
no.
Besides
Weber,
Cowboy.
pardon?
Besides Cowboy.
Well,
There-
Cowboy and Jaws and well, some of the other Erlang servers I don't know about.
Okay, but non-Elixir.
Non-Elixir, not yet, not yet. And I think that's mainly because the language hasn't reached 1.0 yet. So it's not finished. One of the major refactorings of Elixir was with Erlang 17 that deprecated records and introduced maps, um, which enables you to do something like this. Just see here if I can do this. A high B H or yeah, this is a map, and now I can do like this, which is the syntax I was talking about before. Before we had to do records and the syntax I was doing before, and this is one of the really big thing in Elixir, because you can nest these and do structs that resembles into this, so your modules get easier to access. This is a good thing. Yeah. But anyways, I think I'm over time now. So,
it's going to be a short pause while we get the speakers running here, but
Hello?
Evan, would you please say hello? Evan, I think we're good. I think we're good here. Can you hear me?
Okay. Yep, hopefully Google doesn't sign me out again mid-talk. We'll see what happens. Can you hear me? You're muted there. Are we good to go? Hello? I don't want to start until I know that